Hi, I'm Dave Mueller, retired hydrologist from the U.S. Geological Survey and founder of Genesis Hydrotech. In this video, I will discuss the system test. Most of the discussion will be related to TRDI system tests because the TRDI system test provides the user much more information than that from the SonTek system test. To run the system test from Wind River 2, open the Acquire menu and select Execute ADCP Test. The test results will scroll through in a dialog window. Press the space bar or any key when asked to press a key to continue. The test results are saved in the MMT measurement file. The test should be run with the ADCP in the water in the orientation it will be during data collection. To view the test results in Wind River 2, click the plus next to the QA/QC in the measurement control window to show all the measurement tests. Then click the plus next to the ADCP test to show the test completed. Finally, double-click on the test to open it in a dialog window. The TRDI ADCP test produces output that can be a bit overwhelming. To simplify the output, let's look at the parts that are important to us as the user. We can see the instrument serial number and the frequency of the instrument. Down a bit further, we can see the firmware version. The instrument, our beam transformation matrix, is reported in the ADCP test. We can see that this is a custom matrix because the larger numbers in the first two rows are not identical. Scrolling down further is the correlation magnitude, which should be wide bandwidth. Narrow bandwidth can be caused by radio interference. In the correlation table, ideally, we should see high correlation at near zero lags, and then see decorrelation as the lags get longer. High correlation values at longer lags indicate interference is present, which I will discuss more later. The high gain RSSI represents the noise floor below which the signal strength is too low for measurement. Typically, the noise floor is between 40 and 50 counts. The low gain values should be less than the high gain values. If the receive test fails, try moving the ADCP to calm water and retest. If the electronic test fails, it is typically very obvious when you begin to collect data. The wide, narrow bandwidth test can fail if the ADCP is not in the water. HW operation tests can fail if the ADCP is on its side, as this tests the compass and pitch roll sensors. If one of the tests fail, try repeating the test in a different location. If tests continue to fail, complete the other pre-measurement steps and proceed to make a measurement. If the data collected during the measurement look reasonable, complete the measurement. If the tests continue to fail at other sites, follow up with the manufacturer as soon as possible. The StreamPro is more susceptible to interference issues than other ADCPs, primarily because of the cable between the sensing head and the electronics. The longer that cable is, the more susceptible the system will be. The other challenging aspect of interference is that everything is relative. All else being equal, sites with higher backscatter characteristics will be less susceptible to data degradation from interference than sites with low backscatter characteristics. There is no substitute for human judgment in this area. Interference in the ADCPs can take two forms. The first and more benign form is that it will increase the background noise level. This form of interference is indicated by the RSSI values in the PT3 test. A typical StreamPro in a clean environment will have RSSI values on the order of 50 to 70. The RSSI values are not calibrated or normalized to any particular value, so there will be significant differences between beams and between sensors. Elevated values merely indicate high levels of background noise at a site rather than an issue with the StreamPro hardware. Data collected at a site should be reliable as long as the RSSI of the collected data is 10 to 20 counts or more above the background noise level. Normally, as the signal strength drops below that threshold, the correlation will decrease, and when it drops low enough, the data will be flagged bad, which is expected and desired behavior. The negative impact of this type of interference is that the range will be reduced and data is more likely to be marked invalid. The second form the interference can take is that of elevated correlation. The PT3 test receives without transmitting. Normally, as time passes, the background noise should change and the signal will decorrelate. If it does not, the system cannot tell when the data is erroneous. Correlation at a site with favorable interference characteristics will typically decay to 15% or less by lag 3. High correlation values at longer lags do not necessarily mean the data is unreliable. It simply means that the system cannot determine whether or not it is reliable. As noted above, if the intensity of the profile data is 10 to 20 counts or more above the PT3 RSSI level, that data should be reliable. When interference is present, unreasonable values of the water track up and water track air velocities are typical. In the graph of the vertical velocity shown here, there is a definite pattern. The vertical velocity at the surface is positive, and at the bottom it is negative. This is not reasonable. In River Surveyor Live, the system test is run from the Smart page. The results of the test are very simple. Potential failure messages include system battery voltage less than 12 volts, system compass is not working, system SD memory card is not working, temperature sensor is not working. In RSQ, the test is run from the Smart page. The system test verifies the battery voltage, compass, and temperature sensor are all functioning properly. Doing a system test doesn't take much time, but it proves the instrument was operating properly when you made the measurement.